Okay, so now we're ready to kind of take this equation and this graph and kind of identify where the focal point and the directrix are, and then of course the eccentricity we know as 1. So let me kind of clean this up just to give us a little bit of room to write and draw. And we're going to use the equation to help us find out these values right here. So again, remember there are three different standard forms. This is the one you're probably used to seeing really well, but it turns out that in this form right here, okay, this one, or for that matter, this one right here, are really good for finding the length of the focal chord or the lattice rectum. And you may have to go back and watch the movie, but we were looking at equations in this form, and this number here ended up being the reciprocal of the lattice rectum. So I'm going to make a little note here. Okay. This will be the reciprocal of the lattice rectum or focal chord. And then if you look at the equation in this format, okay, this will actually be the length of the lattice rectum. So it's a very, very small, it's a 1/2 unit lattice rectum. So here you have to go down really, really low to where you've got like a 1/2 unit. So basically like 1/4 each way, and that's where the focal chord is going to reside here. So it's going to be very, very, very tight down here. So the focal chord's in very, very, very tight. So what I'm going to do is try to zoom in on this, and then we're going to try to figure out what all this means. Okay, so going across the focal chord, make a little note here. The length of the lattice rectum is 1/2 unit. And so somewhere here is the focal point, and I'll just kind of estimate it right about there's the focal point. And if we go over 1/4 of a unit this way and 1/4 of a unit that way, that's going to be our focal chord. Now again, I can't really get it any closer than that. But so I've got a 1/2 unit focal chord, 1/2 unit. Well, remember that the relationship between the focal chord and the gap was a 4:1 ratio. Okay, this is 4 times greater than that little space right in there. Well, let's see if this. So this is a 1/2 unit. That's a 1/2 unit, and the gap is 1/4 of that. 1/4. I end up getting 1/8. So that little gap between focus and vertex is only 1/8 of a unit. So that means I can now pinpoint the position of the focus. The focal point. Okay, well let's think about this. The vertex was at 3, -5. That's where the vertex was at 3, -5. And so I come up 1/8 of a unit, and that's going to be the focal position. So it's still going to be 3 over. And see, I was down 5, but I came up 1/8. So now I'm down 4 7/8. And so that would be the position of the focus. 3 and then down 4 7/8. The directrix, on the other hand, remember the other relationship is the vertex is right between the focus and the directrix. So if I go 1/8 up to hit the focus, I would have to go 1/8 of a unit down to get the directrix here. And so the directrix would be sitting right here, 1/8 of a unit below. And so I'm going to say directrix. Now, a directrix is not a point, it's a line, and this is going horizontally. So this would be a y equals. And so let's see, I was at 1, 2, 3, 4, 5 down, then I went another 1/8. So I'm down 5 and 1/8. And so that would be the position of the focus and the directrix. Again, using the relationships that were talked about in the previous videos. And of course, the eccentricity, point to focus, point to directrix, is a 1-to-1 ratio. So let me put that down as well. The eccentricity, as it is for all parabolas, is a 1-to-1 relationship. Now I'm going to see if I can use that little Desmos application to get something similar here. So let's see. So here's sort of a general equation. So I'm going to kind of take the equation that we came up with, and so A, which was the x, it was x minus 3. So we're going to take this back to minus 3 if it'll let me here. Try to go back to minus 3. Okay. I'm probably going to have to move this here and maybe have to zoom out a little bit. Okay, so that'll be the first option. And okay, so that's going to be the first. So x minus 3 is there. The lattice rectum now, in this equation, it's in front of the y. And so looking at my original equation, that was a 1/2 that was in front of y. So I'm going to slide L to 1/2 if it'll let me here. 0.5 right there. So that's a lattice rectum of a half unit. And then finally the B, which in this case is the vertical dilation, that was a, let's see, in this format it's y plus, so it was a y plus 5. In a moment I'll go back and check the, so let's see if it'll let me go down to y, make it to a 5. 5, right there. And so, okay, so now let's take a look at this, see if I can move this up a little bit, and kind of compare it to what I had earlier. Okay, so this was my drawing, okay, and so then we're going to kind of check and see, let's see if the Desmos applet allows us to. So yeah, sure enough, oh, okay, so right over here, the student who designed this did a nice job. They kind of said, let's, y equals negative 5 and 1/8. That's the directrix there, 5 and 1/8. I don't know, let's see if I can label that, if it'll maybe, see if it'll label. Oh, there we go. If I click on that, it'll label and say, okay, the focal point is at 3, and that's negative 4 and 7/8. So this actually kind of checks out pretty nicely with the work I got on paper. So there we have it. We've got the general idea for how to take an equation. Zoom back a little bit on here. And so the first phase in the process is going through the completing the square stage to get it to be in a standard form. And any one of these are really good. This one is really nice for graphing because it's pretty easy to see the transformations. These other two are really nice for seeing the focal chord, the lattice rectum. I mean, you could actually use this one as well. You just have to be mindful that in this case, in this vertex form, that number is also going to be the reciprocal of the focal chord. And then we just have to get in there and start using some of the geometric relationships that exist. The biggie is of course, the 4-to-1 relationship between the focal chord and the gap. And then, of course, the equidistance idea allows you to kind of place the directrix. So this week you'll get a chance to do a couple of these, and with a bit of practice, I'm sure you'll be a master in no time. So thank you for watching.